Hello everyone, my name is Catherine I. Merca from the Department of Mathematics and Statistics, and this is our second lecture on algebraic equations. This time we are going to discuss quadratic equations. So our learning objective is for you to be able to solve quadratic equations. A quadratic equation is a second-degree polynomial equation in the variable x. That is, an equation that can be written in the general form ax squared plus bx plus c equal to 0, where a, b, and c are real numbers and a is not equal to 0. In solving quadratic equations, we can solve them by factoring. We use the zero product principle. That is, if the product of two algebraic expressions is 0, then at least one of the factors is equal to 0. That is, if AB is equal to 0, then A is equal to 0 or B is equal to 0. Here are the steps in solving quadratic equations by factoring. If necessary, we write the equation in the general form ax squared plus bx plus c equal to 0, moving all non-zero terms to one side, thereby obtaining 0 on the other side. Then factor completely. Next would be to apply the zero product principle, setting each factor containing a variable equal to 0. Then solve the equations in step 3. Finally, check the solutions in the original equation. So for example, we have the following. Solve the equation 3x squared minus 9x equal to 0. The following are the steps. You move all non-zero terms to one side and obtain a 0 on the other side. But if you take a look at this one, we don't need to make use of step 1 because we already have 0 on one side. Next would be to factor completely. That is, we can factor 3x from the two terms on the left side of the equation, come up with this, and apply the zero product principle, setting each factor containing a variable equal to 0. So we'll have 3x equal to 0 or x minus 3 equal to 0. The next step will be to solve the resulting equation in step 3. So if we have 3x equal to 0, we can divide both sides by 3 and come up with x equal to 0 here, and divide this x minus 3, and you can actually, from here, you can say x minus equal to 0, you can add both sides by 3. We have x equal to 3. Therefore, the solution would be x equal to 0, and the other one is x equal to 3. But you still have to check them whether to satisfy the equation. So we place x equal to 0 here and come up with a value which is 0 equal to 0. It happens to be true. Now if x equal to 3, substitute 3 on x here and here also. So you will now have 3 times 3 squared minus 9 times 3 equal to 0. 27 minus 27 will give you 0. Therefore, the solution set is 0. In solving quadratic equations by factoring, we have another example here. 2x squared equals 12 minus 5x. Okay, we can write it by moving all non-zero terms to one side and obtain 0 on the other side. So to do that, we can add 5x minus 12 on both sides. So come up with 5x minus 12. Then since you have 12 minus 5x, that's 5x minus 12. This will be 0 here on the other side. Then you can factor completely. Let's see, the factors here are 2x minus 3 and x plus 4. 2x times x will give us 2x squared minus 3x plus 4 times 2x is 8x will give us 5x, and negative 3 times 4 is actually equal to negative 12. So the factors are correct. And then apply the principle setting each factor containing a variable x equal to 0. So you have 2x minus 3 equal to 0 or x plus 4 equal to 0. That will give us the following. You can divide both sides here by 2 to come up with x equals to 3 over 2. On the other hand, for x plus 4 equal to 0, you can subtract both sides by 4. So you will now have x equal to negative 4. So we can verify whether x equal to 3 over 2 or x equal to negative 4 are solution by substituting this value. When x equal to 3 over 2, you will have 3 over 2 squared. 2 times 3 over 2 squared equals 12 minus 5 times 3 over 2. This should give us 9 over 4 when we square 3 over 2. And this should give us 5 times 3 here on the other side over 2. 5 times 2. So we have negative 15 over 2. Therefore, when we multiply 2 with 9 over 4, we come up with 9 over 2. And when we get the LCD of 12 minus 15 over 2 here, we'll have 2 as the LCD times 12. 2 times 12 will give you 24. You have 24 minus 15. So it's true. When we check for the value of the original equation and using x equal to negative 4, we'll have 2 times negative 4 squared. 12 minus 5 times 5 times negative 4. And we also come up with a true statement. Therefore, the solution set is negative 4, 3 over 2. The square root property says that if u is an algebraic expression and d is a non-zero number, then u squared equals d has exactly two solutions. That is u equals square root of d or u equals negative square root of d. Equivalently, if u squared equal to d, then u is equal to plus or minus square root of d. So we call that your square root property. For example, you're asked to solve the following, making use of the square root property. It is 9x squared minus 27 equal to 0, and x minus 3, the quantity squared, is equal to 36. For the solution, we have the following. So move all non-zero terms to one side and obtain 0 on the other side. But we already have that one here, so that you can simply add 27 on both sides and come up with 9x squared equals 27. Then divide both sides by 9. So we have x squared equals 3. Then when you extract this one, we'll have x equal to square root of 3 or x equal to negative square root of 3. Verify by substituting x equal to square root of 3 to the original equation. Similarly, you can substitute x equal to negative square root of 3. So substituting will give us true statements. This one. So meaning to say the solution set is negative square root of 3, positive square root of 3. For solving quadratic equations by the square root property, we have another example, that is the quantity x minus 3 squared equals 36. So what do we do here? Steps would be, first, you can extract x minus 3, the quantity squared, by raising this to the 1 over 2. Okay, so if you have 2 raised to the 1 over 2, will give you x minus 3, and this one becomes square root of 36. So x minus 3 equals square root of 36, and the other one would also give us x minus 3 equals negative square root of 36. So that's the first step, meaning to say x equal to 3 plus square root of 36. So if you add both sides by 3, and if you subtract here by add this by 3 again, you will have 3 minus square root of 36. Then you verify whether x equals 3 plus square root of 36 or x equals 3 minus square root of 36 will satisfy the original equation. So substituting the value x, 3 plus square root of 36 squared here, minus 3 squared, you come up with, this is 0 here, so square root of 36 squared. That's true. On the other hand, here you have, again, you substitute x for 3 minus square root of 36. And you still come up with a true statement. Therefore, the solution set contains 3 minus square root of 36 and 3 plus square root of 36. In solving a quadratic equation by completing the square, we have the following steps. First, write the quadratic equation in general form, that is ax squared plus bx plus c equal to 0. Then, if the leading coefficient is not equal to 1, then divide both sides by making the coefficient of the x squared term equal to 1. Next is to isolate terms with variable on one side of the equation and the constant terms on the other side of the equation. Then complete the square. To do this, divide the coefficient of x by 2 and take the square, then add the resulting number to both sides of the equation. Factor the resulting perfect square trinomial on the left side of the equation. So use the square root property and solve for x. Solving a quadratic equation by completing the square is solve for 2x squared plus 5x minus 12 equal to 0 using completing the square. How do we do that? The first step would be to write the equation in general form. As it is already in general form, then you don't have to do that. Just copy that given there. And then, since the coefficient x squared term is 2, you can divide both sides by, you can divide it by 2, both sides of the equation by 2, and come up with the following. So the result is x squared plus 5 over 2x minus 6 equal to 0. Then isolate the terms with variable on one side of the equation and the constant term on the other side of the equation. So you have this, x squared plus 5 over 2x equal to 6. Then complete the square. And to do this, divide the coefficient of x by 2. And take the square, and then add the resulting number to both sides of the equation. So divide the coefficient of x. The coefficient of x is 5 over 2. So divide by 5 over 2 by 2 gives 5 over 4. This one, divide this by 2. Then take the square of 5 over 4. That is 5 over 4 squared will give you 25 over 16. And then that's the time that you add 25 over 16 to both sides of the equation. So x squared plus 5 over 2x plus 25 over 16 equals 6 plus 25 over 16. We now have this value here, x squared plus 5 over 2x plus 25 over 16 equals 121 over 16. Then you can now factor the resulting perfect square trinomial on the left side of the equation. Notice that the left side of the equation is a perfect square trinomial, which can be factored into x plus 5 over 4 squared. This is equal to 121 over 16. From there, you now can take the square root using the square root property and solve for x. So you have x plus 4 equals plus or minus square root of 21 over 20, square root of 121 over 16. You have x plus 4 equals plus or minus. This is square root of 121, it's 11. Square root of 16 is 4. So you have plus or minus 11 over 4. Therefore, you have x equals negative 5 over 4 plus 11 over 4. This is equal to 3 halves. Or, if we make use of the minus there, x equals negative 5 over 4 minus 11 over 4, which will give us negative 16 over 4 or negative 4. But you still have to check, verify that x equal to negative 4 and x equal to 3 over 2 satisfy the given equation. And I'll leave the verification to you. So the solution set is negative 4 and 3 over 2. Quadratic equation in general form ax squared plus bx plus c equal to 0 when a is not equal to 0 can be solved using the quadratic formula below. That is given by the following: x equals minus b plus or minus the square root of b squared. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a, wherein your a is not equal to 0. So solving quadratic equation using the quadratic formula, we have the following example. Solve for the equation x squared minus 2x minus 1 equal to 0. From the given equation, x squared minus 2x minus 1 equal to 0, we see that here a is already equal to 1, and b equals negative 2, and c equals negative 1. So plugging in these values to the quadratic formula, we have minus b there is equal to negative 2, okay, plus or minus square root of b squared, so we have negative 2 squared minus 4 times our a is 1, so 4 times 1, then our c, for ac, so our c is negative 1 here, so we have negative 1 all over 2a, so 2 times our a is 1, which is equal to 2 plus or minus square root of, you can simplify that, square root of 4 plus 4 over 2 equals 2 plus or minus the square root of 8 over 2, which is equal to 2 plus or minus 2 square root of 2 all over 2. And that should give us 1 plus or minus square root of 2. Therefore, x is equal to 1 plus square root of 2, or x equals 1 minus square root of 2. Again, you can verify that these are the solutions to the given equation by substituting these values to the original equation. And come up now with the solution set 1 minus square root of 2, 1 plus square root of 2. In determining which method to use, we have the following table. Quadratic equation form and description can be ax squared plus bx plus c equal to 0. And this one can actually be factored easily. So the most efficient method, if this one can be easily factored, would be your factoring in the zero product principle. So for example, following 2x squared minus 7x plus 3 equal to 0, we can factor this quantity as 2x minus 1, the quantity, times the quantity x minus 3, the quantity equal to 0. You can verify 2x times x will give us 2x squared, minus 1x minus 1 times x will give us negative x, minus 3 times 2x will give us negative 2x. And when you add negative 1x with negative 3, negative 6x, that should give us negative 7x. And negative 1 times negative 3 will give us positive 3. So 2x minus 1 equal to 0, or x minus equal to 0, this one, you can solve x equal to 1/2, or x equal to 3. But if there is no constant term, on the other hand, if you have ax squared plus bx equal to 0, you can use factoring and the zero product principle. And we have the following example. 3x squared plus 27x equal to 0. Notice that 3x is a common factor, so you can factor that out. You have 3x times the quantity x plus 9 equal to 0. So 3x equal to 0 or x plus 9 equal to 0. Therefore, you have x equal to 0 or x equals minus 9. So, in determining which method to use, if you have the following ax squared plus c equal to 0, wherein there is no constant x term, solve for x squared and use the square root property, like this. 2x squared minus 18 equal to 0, so there's no x there. It's simply write it as 2x squared equals 18, divide this by 2, divide both sides by 2, come up with x squared equals 9, then take x equals plus or minus square root of 9. It should give us x equals plus or minus 3. On the other hand, when u squared equal to t, where u is a first degree polynomial, then you can use the square root property. Like such, that is, if we have quantity x plus 2 squared equals 3, this is x plus 2 equals plus or minus square root of 3. They come up with, you can add both sides by 2, negative 2. So you'll have x equals negative 2 plus or minus square root of 3. If you have ax squared plus bx plus c equal to 0, and ax squared plus bx plus c cannot be factored or cannot easily factored, then you can make use of your quadratic formula. That is, you now can have x equals minus b plus or minus square root of b squared minus 4ac over 2a, where a is not equal to 0. So simplifying this, since you have 2 here to be your a, and b is negative 2 and c equals negative 1, you can solve the following. That is, any equation that can be written in the form AVB squared plus BV plus C, this time is what we call an equation in quadratic form. So we'll steer in quadratic equation, but this time some equations can be seen as in quadratic form. So the steps on how to solve equation in quadratic form are as follows. First, identify the algebraic expression v and write the equation in the form av squared plus bv plus c is equal to 0. Then, solve for b using the methods in solving quadratic equations. Use step 2 to find the value of the original indeterminate found in the given equation, and then check the values obtained by substituting it in the original equation. So these are the steps in solving equations in quadratic form. Let's take some example. First example would be to solve 9x to the fourth minus 30x squared equals 7x squared minus 4. Notice that this equation looks like it's not in quadratic form because we have 4, but this is in quadratic form. How do we do that? Identify the algebraic expression v and write the equation in the form av squared plus bv plus c equal to 0. So simplifying the given equation and writing it in this form, we have 9x to the fourth minus 30x squared equals 7x squared minus 4 can be rewritten as 9x to the fourth minus 30x squared minus 7x squared. Okay, then you have plus 4 there. So 9x to the fourth minus 37x squared plus 4 equal to 0. Note that you can rewrite this as 9 times the quantity x squared minus 37 x squared plus 4. So our v now becomes, this one is our v, x squared. So that you can rewrite that as 9v squared minus 37, since x squared is v, so 37v plus 4 equal to 0. And then solve for v using the methods in solving quadratic equations. Note that the equation 9vb squared, 9v squared, minus 37v plus 4 equal to 0 is in quadratic form, and the left side of the equation can now be factored. So you can factor 9v squared minus 37v plus 4 into 9v minus 1 times the quantity v minus 4 equal to 0. And from here, you now have 9v minus 1 equal to 0, or v is equal to, or v minus 4 equal to 0, giving us v equals 1 over 9, or v equal to 4. Again, yes, use step 2 to find the value of the original indeterminate found in the given equation. Recall that v is equal to x squared, so that you can substitute. This time v equals 1 over 9, or v equals 4. But since v is equal to x squared, then we have x squared equals 1 over 9, or x squared equal to 4. V now is equal to plus or minus the square root. X now is equal to plus or minus the square root of 1 over 9, or x equals plus or minus square root of 4. Therefore, x equals plus or minus 1/3, or x equals plus or minus 2. And then lastly, you have to check the values obtained by substituting it in the original equation. So since x is equal to plus or minus 1/3, then verify that one and come up with the following true value. Okay, so I leave this one to you. Similarly, you can verify if x is equal to plus or minus 2, then if it's true, that means to say those are the solutions. So the solution set is composed of negative 1/3, 1/3, minus 2, and 2. Now to solve for y squared minus 5y, the quantity squared, plus y squared minus 5y equal to 30, we have the following. Identify the algebraic expression v and write the equation in the form av squared plus bv plus c is equal to 0. So for the solution, we have y squared minus 5y, the quantity squared, plus y squared minus 5y minus 30, which is this time we now have the form, if we let y squared minus 5y to be equal to your v, then you will have v squared plus bv plus c is equal to 0. Okay, so you have your v is y squared minus 5y, that is v squared plus v minus 30 is equal to 0. Notice that from here, you can actually factor that one out, come up with this. V minus 5 times v plus 6 is equal to 30. So v minus 5 equal to 0, or v plus 6 equal to 0. But since v was rewritten earlier, you can now have v equals y squared minus 5y. So we write y squared minus 5y equals 5, and y squared minus 5y equals negative 6. Okay, meaning to say y squared minus 5y minus 5 equal to 0, as you can suppose that 1, or meaning to say just simply subtract 5 on both sides here and come up with this equation here. You have a is 1, b is negative 5, and c is negative 5. Also here, come up with y squared minus 5y plus 6 is equal to 0. So So y minus 2, y minus equal to 0, y minus 2 equal to 0, or y minus equal to 0. That is y equal to 2 or y equal to 3. For continuation of step 3, it's non-factorable, so we use the quadratic formula and come up with the following values. Can try to solve for this value. The result would give us y equals 5 plus or minus 3 squared to 5 all over 2. So the last step would be to check the values obtained by substituting it in the original equation. So if y equals 5 minus 3 squared to 5 over 2, verify whether it satisfies the equation. Similarly, you have to verify whether it will satisfy y equals 5, whether this quantity y equals 5 plus 3 squared to 5 over 2 will satisfy the equation. So for the first value, 5 minus square root of 3 or 5 over 2, it satisfies the equation. For the second one, let's see, it also is true. So meaning to say, we belong to the solution set. And you can also check for the value y equal to 2 and check also for the value y is equal to 3. Again, let us see. It's true. Similarly, for y equal to 3, it is true. So the solution set now would be 5 plus or minus 3 squared to 5 over 2. And you also have 2 and the value 3. Now let's go to the third example. We have solved 2y to the 2/3 minus 5 to the 1/3 equals 3. So identify again the algebraic expression v and write the equation in the form av squared plus bv plus equal to 0. Notice that there's a 2 there. So we have 2y to the 2/3, okay, minus 5y to the 1/3 equals 3. So we write that one as follows. 2 times y to the 1/3, the quantity squared, minus 5 to the 1/3 minus 3 equal to 0. So meaning to say your v is equal to y to the 1/3. And it can be in this form now. Av squared plus bv plus c is equal to 0. So you will now have 2v squared minus 5v minus c equal to 0. So step 2 would be to solve for v using the methods in solving quadratic equations. So now we have 2v squared minus 5v minus 3 can be factored, equal to 0 can be factored. Come up with 2v plus 1 equal to 0 or v minus equal to 0. Meaning to say v equals minus 1/2 or v equals. Then recall that we have v is equal to y to the 1/3. We can now again substitute to the original equation. Substitute it to v minus equals negative 1/2 or v equal to 3, but your v is y to the 1/3, so you will have negative 1/2 or y is equal to 1/3 equals 3. But when you operate on negative 1/2 raised to the third, it comes up to be y equals negative 1/8. Or y equals 3 cubed will give you y equals 27. Then check the values obtained by substituting it to the original equation. So the values that we get, y equals negative 1/8 and y equal to 227. We come up with true statement. Similarly here, it's true. Therefore, the solution set would give us negative 1/8 and you have your 27. And so for the summary and conclusion, we have the following. A quadratic equation has at most 2 real number solutions. This means that the equation can have none, 1, or 2 real solutions. A quadratic equation can be solved in at least 3 ways, namely, we have your factoring by quadratic formula or by completing the square. And the method of factoring depends on the fact that u times v equal to 0 if and only if either u is equal to 0 or v equal to 0. So any quadratic equation in standard form, ax squared plus bx plus c equal to 0, where a is not equal to 0, can be solved using the quadratic formula, which you are very familiar with. That is x equals minus b plus or minus square root of b squared minus 4ac all over 2a. So this number, b squared minus 4ac, which is inside the square root, is what we call our discriminant. And the value would depend on this discriminant, the value of x. If b squared minus 4ac is equal to 0 here, then the two solutions or roots are real, and both are equal to negative b over 2a. And the solution set is negative b over 2a. Okay? Now, if this one is greater than 0, then there are two distinct solutions. They're both real numbers. Will give us negative b plus or minus whatever that value is, square root of that value over 2a. But if b squared minus 4ac is less than 0, then there are no real solutions or roots. However, there are two solutions that are what we call your complex conjugates of each other. For the references, we have Literature College Algebra Essentials, the 5th edition, and Algebra and Trigonometry by the Department of Mathematics and Statistics. Thank you for listening. We'll proceed to the next video clip.